Welcome to a lesson with Dr. Powell. Let's take a look at how we can come up with identities for cosh and sinh by using identities for cosine and sine. For instance, what if we had cosh of 2x? Well, we can use the definition of cosh, which is cosine of ix. So sinh is negative I, sine of ix, and we can proceed as follows. So this is of x, okay, of x and of x, okay. So this cosh of 2x will simply be cosine of I times 2x. Okay, so we could think of this as being cosine of 2 times ix. Now we're going to borrow some facts about cosine, that cosine actually is a function of a complex variable, and the same identities that apply otherwise for when the input is real actually also apply in this case. So we're going to borrow that idea and take it for granted, but at least it'll help us as we move along. So cosine of 2 times ix, we can use an identity for this, which is we could use cosine squared of ix minus sine squared of ix. So this is an identity. Cosine of 2 times something is equal to cosine squared of it minus sine squared of it. So using this identity, we can work with this a little bit. In fact, let's rewrite sine ix in terms of sinh. So we can write things in terms of sinh and cosh again. So sinh, or sine of ix, that is equal to sinh of x divided by negative I. So in here, let's just substitute cosine of ix for cosh. So this would be cosh squared of x. And then here we can say this is minus sinh of, this is minus sinh of x over negative I quantity squared. Now I squared is just negative 1, and this negative is just positive. So we get a negative 1 out of the square. Working with this negative will be plus. So we get cosh squared of x plus sinh squared of x is equal to cosh of 2x. So we can establish identities from identities of cosine and sine. One of the base identities that we can use just comes from the definition of what cosh and sinh parameterize. They parameterize the unit parabola, x squared minus y squared is equal to 1, where cosh takes on the x value and sinh takes on the y value. So of course, since there are coordinates on this, and then plugging cosh in and sinh in will satisfy this equation. Cosh of x for x here, or you could do t if you wanted to change the variable here, but it doesn't really matter. We'll just do x. So cosh squared of x minus sinh squared of x is always equal to 1 from the unit hyperbola. Just like cosine squared plus sine squared is equal to positive 1 from the unit circle, we have this from the unit hyperbola. Thanks for watching.